And we're back in action here. Okay, so like I just said, that most of the homework problems that you're going to be doing, you want to use this version of the derivative because it is simply easier to use. Now, not all the homework problems use this. This is only for finding slope of a tangent line, instantaneous rate of change, or the derivative, which is f prime of x. If you have to find the average velocity, you want to use the average velocity formula that we looked at way back at the beginning of the lesson here. All right, so that's basically it for the problems. We're going to actually look at a couple examples now using this formula where it gets a little bit more dicey, okay? All right, so, oh yeah, one other thing to note here is that you could write f prime of x as dy over dx, which means the derivative of y with respect to x, or the respect to the derivative of x, okay? Dy over dx. It's just another way to write it there. Okay, so we're finding the derivative of this function, okay, at a particular point. So this is finding the derivative at a particular point, x equals 1. All right, so easier way to do this is first write down the derivative formula, okay? Now, I didn't do that here. I instead took the formula and I just went ahead and I substituted the 1 in place of the x, okay? But, make sure you are using the right formula to begin with. So substitute the 1 in place of the x, okay? Now, notice if you just substitute 0 here, you would be dividing by 0. So you don't want to do that. Throughout the problem, one of the main strategies that you're trying to do is to somehow factor so that this h on the bottom will cancel out. And then you could figure out the limit by substituting the value that it's approaching in. And h should always be approaching 0, okay? Because you're trying to do instantaneous rate of change here, okay? So we want to cancel out this h somehow so we do not get this undefined division of 0. Okay, so we are evaluating our function. We're plugging in 1 plus h in place of x. Okay, and in fact, we're plugging it in place of both x's. And you want to use parentheses to plug it in. Okay, and then you're subtracting f of 1, which is plugging in 1 in place of the x. So it looks like this big, long thing, okay? Because you're substituting 1 plus h in place of the x, both of these x's, okay? And as you can see here, we're using parentheses, so we will be distributing here. We're not distributing the exponent. Remember, 1 plus h squared is 1 plus h times 1 plus h. Okay, you don't want to multiply that wrong. That would cause the whole thing to get really, really, really bad for you really, really, really quick and be really, 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 I keep on saying really, very wrong, okay? So let me show you here, of course, 1 plus h squared is equal to 1 plus h times 1 plus h, or the quick version of it is 1 squared, okay, plus 1 times h doubled, so that's 2h plus h squared, okay? And if you didn't follow that, you can just write it out and FOIL it, okay? 1 plus h times the quantity 1 plus h. Okay, if you FOIL it, you'll get this, okay? Anytime you have a binomial squared, okay, quantity a plus b squared, you want to memorize this, guys, because this is going to be helpful for a lot of stuff down the way. Okay, it's a squared, then you multiply these two together, a plus b, then you double it, so it's 2ab, okay, plus b squared. And that doesn't have anything to do with the derivative there. That is just basic algebra, okay, that you guys need to know, okay? And do not distribute the exponent of 2. That is like the worst thing you could possibly do there, okay? All right, so anyhow, we're going to distribute the minus 3, and then here we're subtracting all of f of 1. So notice I put this in brackets, and then I have my substitutions in parentheses. Okay, so let's keep on moving here. All right, next part of this problem. Like I said, I showed you the shortcut there, okay, that we just did over here. Okay, so that becomes that. We distribute the minus 3 in. So we got minus 3 and minus 3h. And then we have that plus 1. Don't lose that plus 1. That's from this function f of x, okay? Then you have minus f of 1. So then you just work out what this is, simplify all that down. Okay, so combine all the like terms you can here. Okay, and nice thing, minus 1 plus 1 cancel, so you're left with this. Okay, now see, you would still have division of 0 here. So what you have to do is factor the numerator. They both have h's here, so you can take out a GCF of an h. And so what happens is this h cancels out with this h. And then because of that, you can figure out this limit by substitution. You're like replacing this 0 in place of this h. Okay, let me go a step further. Whoops. There we go. Went too far. All right, so you're replacing this h with a 0. Okay, and the answer is a little bit cut off there, so I'm going to have to write it on here. But in the end, as I get giant on you, okay, crazy pen thing. All right, in the end, you have 0 minus 1. So the limit, the derivative f prime of 1 is equal to negative 1 at this particular point. Okay, hopefully that makes sense. Let's go to the next slide for you guys. Okay, now this one, we're not finding the derivative at a point. We're just finding the derivative in general. This is a general derivative for all points. Okay, so f of x equals 2 minus 3x squared. So find the derivative in general. Okay, the general form for all points. For all points. That's what they're basically asking you to do here. So like if we had a particular point, we could plug that in to this general form to figure out that instantaneous velocity. Okay, so same formula as before. So start with the formula. There it is. Okay, now this is where it gets a little bit tricky because you're taking x plus h and you're substituting it in place of, taking this and you're substituting it in place of this x. Okay, so you're replacing this x here with x plus h. So you need to use parentheses and you need to be careful when you do that, okay? That's a very common mistake to kind of substitute wrong there. All right, so you see that x became x plus h, the quantity squared. Okay, and then once again, you want to make sure to do the quantity x plus h squared. You are not distributing that exponent there. You are doing FOIL or you're doing the shortcut. Okay, x plus h squared is equal to, here's the shortcut. The first term squared, multiply the two terms, and then double it. So it's 2xh plus the last term squared. Okay, so that's what happens here. Then we're going to have to distribute the 3. So let's see what that looks like. Voila. Okay, and we're going to distribute the minus 3. Whoops, don't lose that minus. Over here on this part, we had f of x, so you put that part in parentheses, 2 minus 3x squared, and you're distributing the minus sign through. Okay, so I already distributed the minus at this step. Okay, so distribute the minus 3. Notice we have 6xh, okay? That does look kind of ugly, but a lot of these terms cancel out, which is nice, okay? So you could kind of see which ones cancel. 2 minus 2, 3x squared minus 3x squared. Sorry, losing my voice there. All right, so we are going to now, as we often need to do, try to cancel out this h on the bottom. And the ticket to do that is to factor. So we're going to take out the GCF of h. You could take out a negative 3h if you want. But I'm just going to take out an h because really all you need to do is make sure that h will cancel on the bottom so that you can then substitute 0. All right, so factor out an h. Now, since the h's cancel, okay, this is what you would have left. And now you can get your general form by substituting. So you put in the 0. So your general form is negative 6x. All right, now that is off the page, but it will look like, there you go. So that is your general form of the derivative of this function. Okay, so this is what we would call f prime of x. And so if you wanted to figure out a particular instantaneous rate of change, okay, like say at x equals 2, all you would have to do is substitute a 2 in place of this to figure out f prime of 2. All right, and so that's kind of why you do this general form, because it's powerful. It allows you to figure out the instantaneous velocity for any particular point. All right, so hope that helps. There are some other good examples in the book to check out. All right, please, I hope you have your book. Look at these. I think they're on about $7.98 or $7.99. Check those out. Examples 4 and example 5, okay? Please look at those. I know it's a lot of notes here, but you are now doing calculus. Congratulations. All right. I'm going to post the Math Excel, and you guys can have all of Monday to work on it. Hope you guys have a great weekend. Thanks for watching. Bye-bye.